So good afternoon, everyone.
Good afternoon, ma.
You're welcome to this 844 class. Here we'll be talking about alkaloids. Okay, I'm not going to spend much time on this particular section because the slides are very explanatory. I'm going to share the slide with you. I'm just going to focus on the most important points. Now, like alkaloid as we know, are natural products. They are found in plants, and the aspect of plants we can see alkaloid are many. Okay, alkaloid are natural organic compounds. Something about them is they contain nitrogen moiety. There must be nitrogen. That's why they are alkaline in nature, because of the presence of nitrogen. So they are usually in a ring, heterocyclic ring. Okay, the characters, how do we know alkaloid? If you see a compound, how do I identify that this is alkaloid? This compound is an alkaloid. Since we have so many phytochemicals in plants, alkaloid must have nitrogen moiety. Okay, and where anything you talk about alkaloid, you talk about the presence of a ring. There must be a heterocyclic ring, and in nature, alkaloid have bitter taste. So whenever you see any plant that is bitter, it has alkaloid. The more the bitterness, the higher the alkaloid. That's the essence why bitter leaf is always washed. Okay, because of high level of alkaloid. Okay, now alkaloids are mostly obtained from plants. They are very useful in pharmaceutical industry because of their medicinal properties. Now, when you talk about the place we can see this alkaloid, they are majorly in the roots and in the stem. They are found in the leaf, but not as much as root and stem. And that's one of the reasons why leaves are safer than the roots. So whenever you're taking roots, people tend to be more cautious than leaves because the content of alkaloid in the leaves are lesser. The most aspect where we are going to see higher concentration of these alkaloids are in the roots, then stem. You can also see them in the seed. Okay, both root, bark, and stem have higher alkaloid than seed and leaves. Most of the seed has more of terpenoids, while leaves have part of all the phytochemicals, but mainly they have more of flavonoids and polyphenolics. The roots is where we have higher concentration of this alkaloid. Okay, now alkaloid, they are usually solid when extracted, and some of them can also exist in the liquid form. Now, in this alkaloid, the question is that how do we name alkaloid? Alkaloid, unlike any other compound, are not named the way we do other, like if I want to name my hydrocarbons, I know how to name, but alkaloid is not like that because alkaloid differs. So there is no specific system of naming of alkaloid, okay? Because they're very complex in nature. Their structures are very complex. So we often have a trivial names used in naming alkaloids. You can see some alkaloid end in INE, in. That indicates that they are basic in nature. Okay, some of alkaloid are named with respect to where they are obtained from. Like example is nicotine. Nicotine is named from the plant Nicotina tuberculum. So because of this nicotina, that's how we got this word nicotine, and some other alkaloid that we got them from their source. Anybody that enters should mute. I don't want anybody to disturb my class. If you want to ask a question, Then when there's time for you to ask questions, please, so that we can have a free flow. I want to see if it's something we can finish today. Okay, like I said, nomenclature, there is no specific system for naming alkaloid. It's from their source, mainly. Most of the alkaloid are named from their source. Okay, now, how do we obtain this alkaloid from plants? Normally, every natural product, if you want to obtain them, it's by extraction. But that when we are talking about, when I want to do my extraction, if I want to do crude extraction, I want to do extraction because I don't have any particular phytochemical in mind that I want to isolate. But if I have specific phytochemical, I need specific reagent or solvent to do my extraction. So in that case, if I want to extract alkaloid from plants, so I don't want anything that is like flavonoid, I don't like any phenolic, I don't like any terpenoid, I just want only alkaloid. So when I get my plant, I'm going to extract, okay? Pulverize and extract it. When I extract my plant with something like normal methanol. Now, if you want to do extraction, ethanol or methanol is always used because they have higher extracting capacity more than water. So now, that's why they normally use ethanol in herbal medicine is because it extracts more. And why methanol is not used is because of the high toxicity. So whenever ethanol is contaminated with methanol, it can lead to instant death. So that's why but in something like lab, if you want to do analysis, methanol extracts more than ethanol. The difference is not much, but why it is not always used because it's very toxic. Okay, so we don't know at the end, we don't know whether it is methanol that is causing the efficacy from my biological assay or the plant itself. So that's why ethanol is always preferred. Okay, now when we don't have done our extraction, then we're going to treat this extract with 0.1 molar HCl. Then when treated, we are going to have two layers. We're going to have aqueous layer and we are going to have organic layer. Now, this aqueous layer will be basified. Whenever you want to make something basic, it means you're going to add sodium hydroxide. Okay, and when basified, we are looking at taking it to pH of between higher than 8. That's between 8 and 9, not more than 9, okay, and not less than 8. Then after, we are going to extract this aqueous layer with chloroform. When we extract the aqueous layer with chloroform, then we are going to concentrate the extract we obtain from chloroform. The organic layer, in the same manner, we're also going to do extraction there. We're going to, from our organic layer, we are going to separate with HPLC. Meaning that my organic layer is where I'm going to get more of the alkaloids. Okay, so I'll just separate by column, then use preparative TLC. Preparative TLC is a situation where I want to purify my fractions. So my column or HPLC is going to give me different fractions. And some of these fractions might have some contaminant in them, meaning there might be more, a small portion of one layer might contaminate the bigger layer. So I'm using my prep TLC to take away all those ones that I know that are very small, so as to bring out a layer that is very pure, and that should be an alkaloid. So this alkaloid obtained will then further be analyzed. Number one, to validate whether it is what single spot. So after my PTLC, I'm going to confirm my sample using TLC to make sure it's giving me a single spot as expected. Then I will then take to lab to do analysis. One of the analysis I need to do is IR to validate the functional group present. before I go ahead doing my NMR. Okay. Then I have to also validate the molecular mass using either LMS or GCMS. Okay, the essence is I want to validate that the compound I've synthesized or I've isolated and purified. This is the molecular weight to compare with the proposed structure which we are going to obtain for NMR. This process is what they call structural elucidation of unknown compound. But this is for natural product. But if you're doing synthetic product, you have your reactant already and the product. So what you're going to look at is what is the functional group that I'm expecting in the product. If my IR shows me this functional group, I'm good to go. Then I'm going to use NMR to validate what was lost and what was got. Okay, so in that case, I'm not moving from unknown. I am moving from known to unknown, so it's easier. But in natural product, you're moving from unknown. So you don't even know what is there. You don't know. So whatever the system gives you, you have to validate it and make sure that, just like mathematics, I want to prove that this is the structure via this analysis. So that's what you're going to do whenever you're doing analysis after obtaining your alkaloid. Remember, we are obtaining a specific alkaloid. That's why we are looking for single spots. Okay, chemical occurrence of this alkaloid. Like I said, alkaloid are natural products. Okay. I think this slide is a repeated version of the slide. Sorry. This slide is a repeated version of the slide I'm dealing with. I am, because I'm using a laptop. Okay. Chemical methods of identification of alkaloid. How do I identify this alkaloid? Like I said, functional group. Whenever I've done my extraction, purification, I'm going to use IR, or let's call it FTIR, to validate the functional group in alkaloid. What are the functional group we are expected to see in alkaloid? Remember, there must be nitrogen moiety in alkaloid. Okay. Now, there must be transformation which involve chemical tests for functional group. Other methods such as functional group interconversion. Like if I want to do interconversion, like if it's a compound that has phenolic compound, I can acetylate to form a derivative of phenol. In that case, I've validated the presence of hydroxy group, that's phenol. So now I can do transformation of the functional group I see in this alkaloid. One of the alkali functional groups is ammonia, right? NH2 or NH3, imine ammonia. Now, in that case, there might be reaction that I can do to validate the presence of this nitrogen moiety. Now, remember, in some alcohol, we can have functional group like hydroxy group. So when I see hydroxy group, this is what we call, if they said validate that this is this structure, okay? If there's a structure of a compound, I want to validate this structure. That's structure activity relationship. I can say, okay, there's presence of hydroxy group. How do I know? What are the reactions that can validate that this is hydroxy group? I can do acetylation. I can do esterification. So some of these reactions is going to help me to validate that this is hydroxy group present. Okay, so in alkaloid, we can test the presence of the functional group using some reactions. Okay. Now, if I see an alkaloid that has, like when we're going to see some of the examples, if you see an alkaloid that have something like hydroxy group example, after doing acetylation reaction, remember if I acetylate, I'm going to have acetylated derivative of of the functional group, right? So I'm going to form an acetate of that functional group. Then at the end, what else should I do to validate the presence of this functional group after acetylation? Now, if I want to, from the lab, you realize that I can validate the presence of phenolic group using ferric chloride. Now, the reaction now is what I want to see with my. So if there is present, if I add ferric chloride in this compound, there must be a precipitate, right? Which confirm the presence of this phenolic compound in that compound I talk about that is an alkaloid. We will be looking at different types of alkaloid. We will know the functional group in alkaloid. I will know how to validate their presence using reactions. Okay. Why is this? Why are we really studying alkaloid? Like I said, alkaloid is very useful in pharmaceutical industry. If you talk about codeine, talk about nicotine, these are drugs. Why they are called drugs is that when taken in high concentration, they become fatal. Okay, but whenever you're taking something like paracetamol, all those pain relieving tablets, you cannot miss something like codeine must always be there because of their pain relieving capacity. But the concentration that is there is small. And that is why when it's taken without prescription, it can cause liver and kidney damage because they can be fatal. It means that you're taking higher dose than expected, which can be another problem entirely. So they have high biological activities, okay? And they also, now alkaloid, apart from pain relieving, can also affect somebody's brain. If you see somebody that smoke cocaine and the person start having columenta, it's because of the fatal aspects of this alkaloid, because in high concentration, it can cause brain damage. Alkaloid can be a poison. When you see all these herbalists, they said somebody was given poison in terms of herbs. The only part of herbs that can do this poison, most of them is alkaloids. Alkaloid can poison. Alkaloid can even, you can you can give somebody, the person will just drop dead immediately. So it's very healthy and it can be very poisonous. It's highly medicinal. Okay, it has anti-malaria benefit apart from pain relieving capacity. Alkaloid is also useful as antibacterial, antimicrobial properties. So it's very useful. But remember, that is the essence of dosage in natural products. Like I said, alkaloid can have psychoactive properties. It can affect the brain. It can cause hallucination. It can cause somebody being depressed. Alkaloid can be very addictive. That's why I see when people start taking cocaine, they become so addicted that without that, it's as if they are dying. So it's addictive aspect of alkaloid. Now, something like coffee is a simple alkaloid we can talk about. Coffee is alkaloid that contain nicotine. Okay, now this coffee, it's a drug in the sense that, and it's addictive. If they see some people that whenever they see the smell because of the aroma of coffee, they want to take it. And whenever you're used to coffee, it will be difficult for you to stop. It's an addictive stuff. And coffee is not very good. Like I said, if you have watched my video, if you're blood type O and you like taking coffee, it is not for you. Blood type that can do very well with coffee are mostly blood type A. Okay, blood type O's, if you're that person that like coffee, please reduce. Number one of the things it will do to you is going to cause breakouts, because anything your system cannot metabolize becomes poison, causes inflammation. And whenever you're having pimple, inflammation is, your system is saying there's inflammation within me. So it's a sign of inflammation because acne is an inflammatory infection. So whatever happens outside is an indication of what is happening inside. So alkaloids can be that, can be it can be a stimulant. Like people that normally, I want to stay awake, I want to go and take coffee, or you go and take cola. They are all stimulants and they're not very good for your brain. Okay. These are the alkaloids that have psychoactive effects. We have cocaine, we have ephedrine, we have caffeine. Okay, we also have hallucinating alkaloids. We have mescaline, we have tropane, we have ergot alkaloid, the one that are depressants, which are, when taken in high quantity, morphine, codeine, and heroin. These, like codeine and morphine, are always used in small quantity as your pain relieving tablet. When taken in essence, it can bring about depression. Okay, so let's apply caution when we are taking all this. Okay, now, how is this alkali synthesized? Synthesis of it. Whenever you're talking about natural products, we are always interested in how we can bring something to life. Synthesis. Now, most alkaloids are synthesized from a few common amino acids. The common amino acids you know arginine, you know lysine, aspartic acid, tryptophan, triosine. Okay, nicotinic acid is a precursor for nicotine. Purine is a precursor for caffeine. Some alkaloids are also synthesized from terpene. If you look at the slides of terpene, you can see how we can synthesize alkaloid using terpene from that pathway. So we can also synthesize the alkaloid from terpene using mevalonic pathway. Okay. So this is if you look at this biosynthesis of alkaloid, whenever you hear the word biosynthesis, this is what happens in the biological system, in human system. Okay, so it means that by virtue of me being a human being, I synthesize most of these phytochemicals. And because these phytochemicals are in my system, if I take any food, they're going to be splitted by virtue by these phytochemicals, and each respective part of body will assimilate. So anyone that is not in your system and you take it in, there's no place it can fall in. That's why they say your system cannot metabolize it because there's nothing similar. If you go to a place, you go to a wedding, I see your friend. Seeing your friend, you're going there already because there's a similarity. If not, you'll be isolated. Okay, and there's at times and when you go to a place where you don't have anybody that you can talk to, you see yourself living there early or feeling bored. So that's something that happened in our system. When we take something that there is nothing similarity, that thing will go on its own. To be still on its own, the system cannot have because there's no correlation, there's no affinity. So that's the things that can either become a poison or be stored as fats because there's no similarity in phytochemicals. So this is from photosynthesis. We obtain sugar. Okay, that's carbohydrate. Then via respiration, we're going to form acetyl coenzyme A, and which also form about amino acid. Coenzyme A is going to give us terpenoid or sterols, which will further move to saponin and cardiac glycoside. And this can also be obtained from sugar. I can obtain my saponin or cardiac glycoside from sugar. And from sugar, I can also obtain my glycogen, okay, cyanogenic glucoside and glycosinolates. This can also be obtained from amino acid. So alkaloid comes from amino acids. Okay. Then I can also obtain my protein. You know that amino acid is a building block for protein. So I can also obtain my phenol from amino acid. Then from phenol, we have other variants of phenol. We have flavonoid and we have tannins. These are what they call phenolic compounds. So they are from phenol. From melanyl coenzyme A, we can also obtain a fatty acid. Now, these are the things that happen in the system. They happen in the system. That's what they call it, biosynthesis pathway. So how do I obtain alkaloid from the system, from my photosynthesis? Okay, I'm going to obtain carbohydrates, which is sugar. After respiration, so many reactions will occur. They will talk about amino acid. From amino acid, I'm forming my alkaloid. So the pathway of alkaloid synthesis from this scheme is amino acid. How is this alkaloid classified? Which is the most important thing. Classification of alkaloid. Alkaloid can be classified based on the nature of ring system and also on the plant source. The source of plants we obtain them and the ring system that they bear. So based on the plant source, alkaloids are given name by virtue of the family or the genus they belong to. For instance, is morphine alkaloid, opium alkaloid. Opium alkaloid, such as morphine, codeine, nicotine, and paparin, are derived from opium plants. Now, if you look at Ralph Wolfia alkaloid, example is rezapine. This is obtained from Rauwolfia family. Rezapine is an alkaloid that is used in treating hypertension. Okay, so alkaloids can be classified by virtue of their plant source. So if you ask classification of alkaloid, you can do by virtue of their plant source, example, then you give us an example. Classification by the nature of ring they obtain, give us an example. So I want you to understand this and be good there. So we can talk about opium alkaloid, we can talk about Wolfia alkaloid, we can talk about Shintonia alkaloid, Coca alkaloid, Solanaceae alkaloid. So these are from their sources. They should be able to give example of this alkaloid. Now this is a classification again by virtue of the ring, the structure, that's the ring system, the structure of the alkaloid. The first one is by virtue of their source, the plant, this alkaloid were derived from. Second one now is their chemical structure by virtue of their ring system. So major types of alkaloid, the amino acid precursor are well known in each of those. Now, whenever you're looking at this particular slide, you can be asked about classes of alkaloid and with their respective amino acid source. So whenever you're learning this slide, learn alkaloid and the amino acid that they came from. Now, if you're talking about a class of alkaloid, you're talking about pyrrolidine. Pyrrolidine has amino acid precursor as ornithine. An example of this alkaloid is nicotine. So the class, the structure, their precursor, and example. Now, the same ornithine is a source of cocaine. Nicotine and cocaine and atropine has something similar. they are obtained from the same amino acid. I mean, if you look at their structure, you can see they have something similar. The pyrrolidine is inside tropane. Difference is that there's extension of the ring, but they are the same. So if I can know my pyrrolidine, I've known my tropane because they're the same precursor. Okay, so I can just talk about the example. Example I'm talking about is example by virtue of their structures. Another one that is from ornithine is also pyrrolidazine. All of them have nitrogen inside the ring. And we also have piperidine, which is a source as lysine. Example is quinine. We have quinolizidine. Quinolizidine is amino acid of lysine. Example is lupinine. Isoquinone. Now, we're going to, when you see isoquinone, so you are going to also see quinone and see the difference. Isoquinone, difference between isoquinone and quinone is the presence of the nitrogen. In isoquinone, the nitrogen is at the side, while in quinone, the nitrogen is at the center. So if isoquinone is at the side, the quinone is going to be at the side. We're going to see it on the upcoming slides. We're going to see the example of quinone. Okay, so quinone is coming from tyrosine. Isoquinone is coming from tyrosine. Example, we have codeine and morphine. We also have the last one on the slide, indole. Indole alkaloid. Indole alkaloid and isoquinone, they have this similar thing in common. In the sense, they have one aromatic ring. Then in iso, I have one aromatic ring and two aromatic rings. One is bearing nitrogen. While in indole, I have one 6-membered, which is aromatic, and the other one is 5-membered. That's what we call tryptophan. Tryptophan as a family. So you should be able to know at least 4 of this. At least 4 of this. Knowing their names, knowing their amino acid source, and example. So you should be able to know that as being written on the table. It's going to help because we don't know how the question is going to come. So that's why it's very important for you to prepare. The essence of being in the class is when issues are raised up like this, you should also point some things down that will assist in your revision. Okay, this is an example of tropane alkaloid. Now, tropane alkaloid, you can see the structure. And this tryptophan, like tropane, is a psychoactive alkaloid. Okay, we see look at their source. We can get from belladonna, jimson weed, hebane, mandrake, and coca tree. So these are the source. Now, when you're given a compound, what you should know that you have to look at what are the functional group here. If you look at it, we have hydroxy functional group. We have supposed to acetate functional group. Now, look at this other one. In this ring, what are we having? The other ring, we have aromatic ring. The other ring, we have, this is a ring that contains the nitrogenous ring. This is a ring that makes this compound alkaloid. The ring that contains tertiary amine. Because of this, that is what made this alkaloid. to be alkaloid. Without that ring, there is no alkaloid, nothing that shows alkaloid. So whenever I see a compound and look that's supposed to be an alkaloid, there must be a part of the ring system that bears nitrogen or nitrogen derivative. Another alkaloid. Pyrrolizidine. These are the source of this pyrrolizidine. The structure, remember we're talking about alkaloid, classification of alkaloid. The first one we did based on their sources. Now, the one that is important to us is based on their structure and the system. So we have another one called pyrrolizidine alkaloid. Okay, this is an alkaloid that you can see where the nitrogen ring are. It's unlike the other one that is inside the ring. This one is in between two rings. And we have functional group, okay, of hydroxy group in this one. Apart from the nitrogen section of the compound, every other thing you're talking about is alcohol or hydroxy functional group. So this is a alkaloid called retronicene. Retronicene. So it's an example of pyrrolizidine alkaloid. And it is ground cell type of alkaloid. Ground cell type of alkaloid. Okay, this is another class of alkaloid, piperidine. If you look at piperidine, you can see that there is nitrogen, there is cyclohexane compound, and there's also another one, aliphatic ring system, bearing propyl. Okay, and where we see is where we are seeing the nitrogen. That's where the ring that makes it an alkaloid. This is called conene. Conene. This is a hemlock type of alkaloid. You can call it pyridine or piperidine. This is a very type of alkaloid that can become poisonous. They call it poison hemlock or Indian tobacco. So this is their source, the source of this conene. Look at the structure, it's very simple. Cyclohexane that have secondary nitrogen. Then with my propyl attached. So this one can easily be drawn. So you have to master the one that you want to be familiar with. Because there's no how they will ask you without asking you this classification based on their ring type. Okay, indicating the nature of the amino acid they are being synthesized from. At times it can be asked example. So just know all this. If I'm looking at pyrrolidine pyridine. Pyrrolidine pyridine is a class of alkaloid that we have example as nicotine. Look at the structure of nicotine. Okay. So remember from the previous slide we indicated all the amino acid source. So have to go back, draw the structure of this amino acid, the structure of this alkaloid, their class, and the amino acid that it can be obtained from. Be conversant with at least 4 or 5. Okay. Remember, you're here to master. You are mastering. Okay, another class of alkaloid is, call it purine alkaloid. That's the alkaloid you obtain from coffee. So whenever you're drinking your coffee or your caffeine, this is what caffeine look like. This is what caffeine look like. You can see it's tertiary amine. Into two places. But into 3 places, 3 tertiary amine. And then we talk about 2 carbonyl functional group. Okay. Now, all the ammonia, all the tertiary and amine that we saw, they are all inside the ring, caffeine. Caffeine can come from a coffee, can come from chocolates. Okay, so chocolate and every tea have some percentage of caffeine. But when it becomes very high, that's when it becomes of concern. That is why coffee is caffeine. There's some coffee you say they say decaffeinated. Decaffeinated does not make it zero coffee content. It makes it that the coffee content is now minimal, that anybody can take it without being without the side effect that is being linked to coffee intake. So does not mean that there's no coffee. That's not true. There's no caffeine. That's not true. We also have another class called quinine. We have quinoline alkaloid. Now look at the quinoline aspect of this compound called quinine. This is the structure of quinine, the anti-malaria tablet you know about. And this quinine is coming from cinchona tree. Okay, you can also get it from globe tassel. So this is the structure of quinine. Quinine contains quinoline. Quinoline is this aromatic ring that contains nitrogen. If you look at quinine and isoquinone, the difference is because the position of this nitrogen that makes quinine to be isoquinone. Okay, but this is quinine. In this quinine contains quinoline. The type of structure we saw in quinine is quinoline type of alkaloid. Okay. Now look at isoquinoline alkaloid. If you look at difference between alkaloid and isoquinoline, it depends of the presence of this nitrogen is the difference. Example of isoquinoline alkaloid is morphine. So this is a morphine. The two ring, one is aromatic, the other one is not aromatic, it has tertiary amine. It is the isoquinoline moiety. This can be obtained from opium poppy, okay, blood roots, Dutchman's breeches, squirrel corn, golden seal, and others, fumatory. These are the sources you can obtain this opium or morphine type of alkaloid, which is from a class called isoquinoline alkaloid. Ergot type of alkaloid is from a class of alkaloid called indole or indolizidine. Indolizidine contains ergot type of alkaloid, meaning, now look at this structure. Where is the alkaloid from? You can see the tertiary amine. You can also see another amine that is not tertiary. So this is what we call indole. This is indole, and this compound is called ergot. Example of this ergot is agonovine. Agonovine is an example. Okay. So this is a class. Another class also is quinolizidine. This is the structure, the moiety of quinolidine, the one that contains. So this compound is called lupine. Okay, so the figure is lupinine. So lupine can be obtained from lupinus, golden chain, false indigo, and others as shown. Okay, the essence is that being able to destruct, this is the simplest of all that I've seen so far. I have a 2 heterocyclic ring that is connected by nitrogen, and I have primary alcohol attached to it. Okay, so go and learn about all the structures and at least be conversant with 3, 4 at least, that you can know their names, their source, the structure. Their source, I mean, is the amino acid they are obtained from and their class. So we have a steroidal alkaloid. or glycoalkaloid. This is what we talk about in tomato or salanine. We can obtain this kind of alkaloid from tomato, from Irish potato, from nightshades. Nightshades are all the solaniums. Okay, so we can obtain this kind of alkaloid from them. But look at this alkaloid, very, very big alkaloid. You can see where is the alkaloid moiety. Wherever you see the nitrogen is where you have your alkaloid moiety. From so far we've seen, you can see there is always presence of hydroxy group in most alkaloids. So when I want to do structural derivative or to validate the structural activity of this compound, I'll go for the reaction that this functional group can undergo. Okay. Okay. Then we have amine alkaloid. Amine alkaloid is example mescaline type. In this mescaline type of alkaloid, this alkaloid they say this phenylamine amine alkaloid. This is one of the alkaloid without hydrocyclic ring nitrogen atoms. Does not have that hydrogen. Normally, all the alkaloid you've been seeing, the ring are always in, nitrogen is always inside the ring. But when you come to this kind of alkaloid called mescaline type, there's nothing like hydrocyclic ring that bears nitrogen. Okay, so example is the masculine. So if they can ask you a question of that of alkaloid without nitrogen in heterocyclic ring, and I know you know the alkaloid, you can give us an example. Now we are looking at the precursors of alkaloids. Aside from classification, the precursors are very important. Knowing their source is very, very important. Most alkaloids are obtained from four different amino acids, which are lysine, phenylalanine, tyrosine, and tryptophan. These are the four basic amino acids that we can obtain most alkaloid from. Okay, example of amino acid as precursor. Okay, this amino acid, you can see my lysine, you can see my phenylalanine, you can see my tryptophan, you can see my tyrosine. So you should be able to also understand some of these structures. So you can link into the class of amino acid which they are precursor of. Okay, alkaloids that are derived from lysine. What are the alkaloids that we can obtain from lysine? Okay, now the structure of 5-lysine derivative alkaloid are already shown in slide 5. If you go to slide 5, you're going to see the structure of this lysine. Okay, maybe we should go back to that slide 5 to see the structure we're looking for. Okay. So some of these are sedamine. We see pelaterine. We can see cydopelaterine. Okay, these are the alkaloids we can see from the back of pomegranate tree. Remember, alkaloids are always obtained more from the bark, from the roots, and from the stem. Okay, we also have lycopodene, which can also be obtained from the species of Moss lycopodium. You can see that it means that this lycopodene the name is obtained from this plant called lycopodium. So that's some of the things you need to start understand, that some of the alkaloids are from their plants that are obtained from. So there's nothing like a nomenclature for them. They just have trivial names. Okay, this is a lysine-based alkaloids. This is example of the lysine-based alkaloids. We can see the pelentrine. We can see the pseudopelentrine. What's the difference between pelentrine and pseudopelentrine? You look at it very well. That in pseudopelentrine, there is complete pelentrine. Difference is that the ring size is extended and we have methylated. So when it was extended, I have methyl connected to oxygen functional group. So okay, sorry, I was disconnected because of light in 30 minutes. I was disconnected because of light. So I have to share the slide again. So we'll continue from where we stopped. Don't know whether it's doable to finish this slide today. Even if I didn't finish it, it's something you can read up. Let me see. I will just go to what is important and point out for you. These are some of the things you can read and understand. So let me just point out what you need to focus on. That has been interrupted in school here. Okay, so we have to also, this slide is talking about some of this lysine derived alkaloid. What are their sources? Where are they obtained from? So that whenever you're taking something, you can tell yourself this is the alkaloid from this thing I'm taking. This is the nature of the alkaloid. Okay. So most of the intermediate of this lysine based alkaloid is, the intermediate is piperidine. Okay, so this is most of the intermediates we have for this. So we have the origin of peletrine, sardamine, and hallucine. This is their origin in terms of reaction. Okay, this is the compound from which all this lysine-based alkaloid are being synthesized. If you look at the reaction, they are always using the same method, decarboxylation, right? But now, whenever I'm removing CO2, I'm decarboxylating. But what did I add before I decarboxylated? What if you look at the first compound I added, what is it? I'm adding, what is the structure of this? Who can tell me the nature of this compound I added here? Somebody can unmute and tell me the first structure of the compound, what is it? This is carbonyl carboxylic acid, right? The first, if you look at the compound, I have carboxyl functional group terminal and I have was ketone, okay? And now the difference between them, they are still the same thing. But what difference between them is what I'm adding. The first compound, have methyl. Now the second when I have my methyl, what I'm forming is peletrine. Then the second compound, instead of adding methyl, I'm adding phenyl. That's phenyl. So the third one, instead of adding phenyl, I'm adding what? Ethyl. The first one was methyl, the last one was ethyl, the second one was phenyl. So that's what brought about the peletrine, sodamine, and hallosaline. So what we need to do is to look at the reactants and look at the product, look at what's changed for you to know. So these are a very, very simple reaction to learn if you want to learn it. Now, this is another alkaloid derived from phenyl, aniline, and tyrosine. Phenyl, aniline, and tyrosine are classes of amino acid. So we can obtain this alkaloid, dopamine, epinephrine, mescaline, morphine, codeine, ephedrine. Now look at this. So meaning that even if I don't want to forget anything from this phenyl and tyrosine alkaloid, I cannot forget the morphine and codeine. Look at the difference between morphine and codeine. They are the same thing. What differs in them is in my morphine, I don't have any methylated. While in my codeine, I have methylated. So when I want to convert my morphine to codeine, I'm going to methylate. If you look at the two hydroxy group in morphine, you only have one in codeine. They don't have been methylated. So that's how to convert my morphine to codeine using methylation reaction, which is acetylation. Okay. Okay. The biosynthesis of mescaline. How do we synthesize this mescaline? That's where biosynthesis. When you talk about biosynthesis, talk about synthesis. How do I do this in the human system? How is it done? The human system. Okay. Okay, let's go through it. Now, what I'm using is phenylalanin. Phenylalanin. Phenylalanin is a precursor from amino acid. Okay. Now, phenylalanin is going to undergo reactions. First, it's going to undergo hydroxylase, okay, to form tyrosine. Decarboxylation to form tyramine. Another hydroxylase is going to form what? Dopamine. O-methyl transferase and S-adenosine. Another reaction, these are the reaction that this one is O-methyl transferase. Okay, it's going to do that on that reaction under hydroxylase again, and another complex reaction. So these are the reactions for mescaline synthesis. Nobody will ask you to talk about the reactions of mescaline synthesis. You just know that my mescaline, remember mescaline is the only compound that does not have nitrogen moiety in a ring. The nitrogen molecule is aliphatic, is not in a ring. This is only compound. And you can see the complex reaction it undergoes in human system for it to be formed. Okay, so just understand about the simple thing of mescaline. Now, the first total synthesis of mescaline. This is what happens in the lab. The other one happened in human system. So we can see the reactions that occur in synthesis of mescaline. And at the end, what is formed is my mescaline. What matters is what was formed is mescaline. So these are the reactions. First is PCl5. What happens whenever you're looking at this reaction? Look at where the reaction is taking place. My PCl5 is like I'm going to form acid chloride. So I'll go to the acid functional group. That's exchange of hydroxy radical and chlorine. Okay, so when I want to hydrogenate using palladium and barium sulfate, and from my acid chloride, I'm going to form an aldehyde. Okay, then under methyl nitrogen and base, I'm going to nitrate the compound. Now, in that case, look at what happened. I've added a methyl and NO2, okay, which will undergo other reactions, including reduction, to form my mescaline. Assignments. While many of the reagents shown above may be unfamiliar, you should be able to select a modern-day counterpart that would achieve the same outcome for each of the steps shown in the figure. So when I'm looking at this reaction, there are some things that I said, where will I get this from? Now, this is zinc in acetic acid. The other one is methyl NO2. Okay. Now, some of these reagents, they may look obsolete. So now, the assignment is for you to go and check out the method for total synthesis of mescaline. So look at the method and the reagent they use and compare with the one given to you on this slide. And see if you can come with something easier for you to know how to go about the total synthesis of mescaline. So this is another alkaloid derived from tryptophan. We have one of them that is very familiar with us is our quinine, which is an anti-malaria. Now, this serotonin is a very important alkaloid. Serotonin is that is what alkaloid that nature releases when you are asleep, especially when you sleep between the hour of 11 to 2. Serotonin is an antioxidant that helps you repair your cells and heal while you sleep. So many of us, because we are always busy, we are skipping sleep from 11 to 2. So some of us, even around that to now, want to start sleeping. That case, you're missing this serotonin. And that is what is causing oxidative stress, eye bag, because nature have told you that day that you did not sleep. You wake up weak because there was no healing process that took place when you were asleep. So it's a very important natural alkaloid that everybody needs to survive. When you skip missing serotonin, you end up having some oxidative diseases. Okay, one of the signs, you start having big tummy, start having gray hair, early gray hair, is a sign that there's stress occurring in your system. So this is more example of alkaloid. We have quinine. If you remember the first slide, we talk about this quinine. We have nicotine, the one from your cocoa or from your cola. We have rezapine. We have vinblastine. This vinblastine is an alkaloid that has been used in treating cancer. They've been using it to treat cancer and chemotherapy, but the essence of some of these things, they are very loaded and they have side effects. That's some of the side effects you see when cancer patients are treating cancer using chemotherapy. See them losing their hair and everything. So malaria, which is a source of our quinine from a cinchona tree. Okay, this is a quinine. So if you know cinchona tree, so you don't need to go and buy your quinine. Kukuma go and pick some leaf and be drinking to prevent malaria. Remember I said leaf, I did not say stem. Okay, this is talking about malaria and cinchona tree, how it was obtained, everything about it. I remember some of these does not leave you without side effects. So as of 2026, quinine is no longer recommended by the World Health Organization as first line because of other substances that are equally effective with fewer side effects. Because of the side effect that for this quinine is too much. Okay, some of us, whenever you take this quinine, it start itching you. Start having, so the side effect is too much. That's why it was not recommended, but people still take quinine. Somebody want to buy and they say, I want chloroquine. That chloroquine is from quinine. Okay, this is a synthesis of this chloroquine. Okay, this is a chloroquine we can obtain from quinine. If you look at the first reaction, we are going to acetylation reaction. Then we acidify. Then because we want to remove alcohol, form of ethanol. Then we basify the carboxylates. We are going to draw BOCl3. Then at a high temperature, we are going to add our quinine functional group from alkaline and primary amine to form our chloroquinine. Amine, quinine. You can see this similarity of amine and quinine. Cocaine. This is the cocaine. Cocaine is a crystalline tripone alkaloid. It is obtained from the leaf of coca plant, not cocoa. Coca is a friend from cocoa. That's why we call it cocaine, coca. Coca coca of alkaloid. In is talking about alkaloid. So this is also a stimulant of central nervous system, which can cause depression, which can cause columenta. It has some side effect, okay? Can affect the eye, the throat, and nose. Okay, so whenever cocaine is being used, we are always using it whenever you want to give an injection. That's why I see somebody, you're doing operation and they put injection for you. They inject that particular place you're doing a surgery. What does it do? It's going to numb that place. You will not feel any pain because they're giving you high dose of pain relieving tablets. What does pain relieving tablet do in essence? What they do is to numb, make your brain not to remember that place, that the cells there are alive. So they're going to numb the cells there. They will not be active for that period of time. And that is why after the effect is gone, okay, you feel more pain. This is what happens to people that are doing all this karak, or all these people that does this strong weight. See them, they can, or some people that want to perform on stage, want to do something that is weird, they cannot do naturally. When they take this, they feel nothing. The people that are high killers, when they want to kill somebody, their eyes is not more normal. So that's why they take this. Okay. So when they take it, even if you're beating them, they're not feeling the pain at that moment. They take high dose. And that's why some of them, when they start aging, you start seeing their body is shaking, start become. That's the side effect of all this cocaine. They start having some of these diseases, Alzheimer's diseases. So cocaine is it. And in minute quantity, you're being given for surgery so as to not feel the pain of the knife. This is a synthesis of cocaine. It can also be synthesized in the lab. Despite that we can obtain it from nature, it can also be synthesized in the lab. So we also have another alkaloid called opium alkaloid. The opium alkaloid, like we talk about, we have morphine, we have heroin, we have codeine. These classes of alkaloid are similar. From morphine, you can get your codeine. From morphine, you can get the heroin. The different thing is their hydroxy functional group of morphine is being acetylated and methylated. Now, if you look at phenanthrene moiety, nucleus are there, ether bridges are there, phenolic hydroxy group are there, we have alcoholic hydroxy group, we have tertiary amine. It's something that are similar structures. Then all of them have one hydroxy group. But if you look at the first one, have the morphine has 2 hydroxy group, the heroin have 1 acetate and 1 hydroxyl. The other one, codeine, has methylated, methoxy, and hydroxy. So that's only places they differ. So that's why they are from the same family called opium alkaloid. So when you know one, you know all. That's a. This one is piperine. Piperine is alkaloid formed from opium. It's formed from opium. And look at the structure of piperine. There's something we are going to talk about. You're going to notice here is isoquinoline alkaloid. The first 2 structures of aromatic ring with nitrogen by the side is isoquinoline. Okay. This is very useful in muscle relaxants. So it's always used in vasodilators. Or say to calm the nerve, especially when you're talking about high blood pressure. So this is very, very important. Okay. Vasodilators cause blood vessels to expand, thereby increasing flow of blood and treating problems resulting from poor blood circulation. That's one of the things that causes high blood pressure, when the veins are very tiny, that the blood has to exert pressure before it passes through. So we say the blood pressure is high. So what these vasodilators do is to go and expand that blood vessel, so blood can easily flow without stress. So when a compound like this papaverine is being given, that's what it does. So as to calm all the muscles, so that blood can easily pass through without exerting pressure. This is the synthesis of this papaverine, it can also be synthesized in the lab. I'm not going to stress on the synthesis. It is caffeine, the popular caffeine, Drinking too much of caffeine can cause health problems such as restlessness and shakiness. So when people are always taking coffee, can end up having shaky, insomnia, headache, dizziness, fast heartbeat, dehydration, and anxiety. For me, there's nothing good. Another thing is that caffeine might improve blood flow, decrease the likelihood of depression, stimulate brain function, and protect against Alzheimer's and Parkinson's disease. But caffeine is well absorbed by the body, and the short-term effects are usually experienced between 5 and 30 minutes after taking it. But what of the excess of it? This is what it can cause you. So meaning that it's now, like I said, for people of blood type O, there's no benefit that this caffeine will do to your system, because your system cannot deal with it. It can only increase your inflammation. So please, it's only blood type A that this caffeine can be beneficial to. So don't say, it can prevent Parkinson's disease and you go and be taking small. You end up having inflammation for yourself. What are the chemical reactions of alkaloid? Alkaloid can undergo glycosylation, acylation, reduction, oxidation, and methylation. These are the reactions that is possible. How can we test for this alkaloid? In the lab, when you use Dragendorf reagent, there will be a color change in the presence, that validate the presence of this alkaloid. If there is alkaloid in a solution, we're going to see orange or orange-red precipitate using Dragendorf. When you use Dragendorf and sample has alkaloid, so the more intense the color, orange or orange-red color, the higher the concentration of alkaloid in that sample. So this is assignment. Assignment is examples of alkaloid. Right? What are the 5 examples of alkaloid? Write the classes they belong. What are the chemical reactions of alkaloid? What are the major sources of alkaloid? What are the reagents for alkaloid? How do we detect the presence of alkaloid? Apart from Dragendorf, other reagents you can use Meyer. Another reagent we can use. So find out the reagent I can use to validate the presence of alkaloid in the laboratory. So with this question, this assignment is virtually tells you about what you expected to know in this particular slide of alkaloid. Like I said, the classes of alkaloid and their amino acid which they belong to. Please, what are the major sources of alkaloid? Go and use these assignments and other one that I've said when I was teaching this course to revise the slide on alkaloid. Nobody will ask you some of those synthesis of quinoline, quinine, and all stuff like that. Most of them. So these are the things you need to know about alkaloid. Just understand that some of these things are what can be synthesized in the lab and obtained from nature. So let me get your questions. I'm going to share the slide with you. So mute yourself and ask questions. Okay, I assume that we don't have any question. Please, like the rule goes, the assignments at the back should be solved and share on Google Classroom. With addition to what was written here, what are 5 examples of alkaloid? Write the classes each belong and their amino acid they are obtained from. Their precursor amino acid. So that's what I added there, and their precursor amino acid. What are the chemical reactions of alkaloid? What are the reactions that alkalis can undergo? What are the major sources of alkaloid? And what are the reagents for alkaloid? Ask your question. Oh, Jesus, I'm tired. You don't have question. So this assignment, like I said, course rep, I'm going to share this slide with you. Let me highlight this assignment, copy it out with the addition I gave, place it on the platform so I can add it for you as assignment submission on Google Classroom. So you have from now till Monday to do this assignment. Okay, I think this is the last aspect of your class. Go and look for past questions. Look at how questions like this have been asked. Please, whenever you're reading chemistry, don't read without having your biro and paper. Make sure you write something down. Even if you're not going to go through them again, be writing. Even if it's something that nobody can read, you're just using that to stick to your brain what you've learned. Go through all the slides, all the questions that was asked part of your examining question, and your answer. It's not a question of what is 1 plus. So in the absence of any question, I will see you on Google Classroom. Thank you very much.
Thank you, ma.
I see you. Thank you very much. If you have any personal question, you can also chat me. I wish you success in 844. People that did 844 last, I believe that we have more A's than B's. I don't think anybody have C. I don't know. But I want you to know that this course is something you can pass and have SSA. When I was doing my master's, I had 844. Was it 84? It's something. So, and if I know what I know by now, I know I'm going to get 90 something. So I want you to know there is a doable A. It's not a course can have a very good A. Just go through, answer all the questions that you were given on Google Classroom. Answer the ones we are talking about today. Everything you submit on Google Classroom, don't just copy and submit. Make sure you understand what you're submitting, so that your question cannot be far from what we talk about in class or the assignment you are giving. But still, even if at the end, if I bring out some of this particular question now, see some people still fail it. So go and read. So I wish you the best. Thank you.